Memento design pattern is a behavioral design pattern. It offers a solution to implement undoable actions. This can be done by saving the state of an object at a given instant and restoring it if the action performed since need to be undone. Practically, the object whose states need to be saved is called an originator. It creates a memento and uses it in future to undo. The object that is going to maintain the state of the originator is the memento, which is just a POHO. The caretaker is the object triggering the save and restore of the state. Keeps track of multiple memento like maintaining safe bits. The memento object should expose as little information as possible to a caretaker. This is to ensure that we don't expose the internal state of the originator to the outside world, as it would break encapsulation principles. However, the originator should access enough information in order to restore the original state. As we can see in this class diagram, the originator can produce and consume a memento. Meanwhile, the caretaker only keeps the state before restoring it. The internal representation of the originator is kept hidden from the external world. Here, there is a single field to represent the state of the originator, though we're not limited to one field and can have as many fields as necessary. Plus, the state held in the memento object doesn't have to match the full state of the originator. As long as the kept information is sufficient to restore the state of the originator, we're good to go. Here we can see an example of a memento. We have our design class which has our main method. Here we have a live object where we have our memento, and we will call the function save to memento 3 times, and finally we will restore from memento. So if we go to save to memento method, we return a memento object. The memento class is an inner class for class live. Here is our class. We have our private attribute. We have our methods, and we set the time to time. And here in our method set, we set this time equals time. And in our restore from memento, we receive an object for us to tell the program which memento we want to restore. In this case, we will be restoring the number 1, which will be 1000 AD since it starts from 0 to so on. So if we run the code, we can see we first add 1000 BC, 1000 AD, 2000 AD, 4000 AD, and time restored from memento gives us 1000 AD. And if we change this to 0, we receive the 1000 BC. So basically that's a simple example for a memento. Moving on, we go to the solid principles. The memento design pattern can implement all 5 solid principles. In our first case, the single responsibility principle refers to that each class should maintain a single responsibility, which in our example we can see it does. Every class have a single activity responsibility to carry on. Secondly, the open-closed principle. We can easily extend a class by adding more serializable objects without modifying our original class. Then, the least cop substitution principle states that all derived classes must be substitutable with the base class. We could implement 2 derived classes that derived from a generic enough interface so that all mementos have a common interface. The interface segregation principle can be implemented in the existence of interfaces, keeping the idea of many client-specific interfaces instead of one general-purpose interface. Finally, the dependency inversion principle can be implemented if our classes depend upon interfaces or abstract classes instead of concrete classes and functions. In our MVC model, pattern stands for Model View Controller. This pattern is used to separate applications concerns. The model represents an object or Java POHO carrying data. It can also have logic to update controller if its data changes. The view represents the visualization of the data that the model contains. Finally, the controller acts on both model and view. It controls the data flow into model object and updates the view whenever data changes. It keeps view and model separated. Thank you.